Okay. Hi friends, welcome to this week's Antrea live show. Today we have two new friends join us, and Anlan and Yongming. They are from Antrea team, and today we are gonna talk about a new feature that uh available in Antrea 1.6. Would you like to say hi to our audience?
Okay. Hi everyone. My name is Anlan. I have been working on project Antrea for a year, and I'm mainly working on Antrea network flow visibility project. And I also have my team member Yongming here. Hi Yongming.
Hi everyone, my name is Yongming. I work from Antrea team at 1.5 year and mainly focus on the flow visibility stuff. Currently, we are building the solutions for the monitoring and give the visibility to the user with the port traffic and extra and Anlan and I and also we have other team members are working on these features to maintain it and create new features.
Okay, thanks for telling us a little bit about yourself. And also we have Zach and Scott here with us. Hi, Zach and Scott. And for all the audience, if you want to interact with us, please log into your YouTube account so you can leave your comments uh, so you can post your comments and we can show them in our stream in our live show. Okay. So Alan, would you like to go ahead and share your screen to tell us a little bit about this network visibility?
Yeah, sure. Let me share my whole screen. Okay. So you guys can see it right now. Yep.
Yeah, right.
Okay. So so the main purpose of our project is to collect the network the network information in the cluster and to visualize those kind of informations. And today, our main topic is to introduce a new visualization tool named Grafana Flow Collector, so that we can visualize our network flows on those dashboards on Grafana and help us to understand the things happen currently in our cluster. I think I'll start with a very helpful architecture diagram here. So in our project, we have two main building blocks. The first one is called Flow Exporter. So Flow Exporter is running as part of our Antrea agent, and the main functionality of our Flow Exporter is to periodically polling from contract. So contract will basically capture all the packets running in the node and also identify which packets is belong to which connection, so that our flow exporter can read from those contract table and to gather those kind of flow record information from contract. And then our flow exporter will export this kind of flow metadata to our next stop, which is flow aggregator. This is our second main building block. So the main functionality of flow aggregator is to aggregate and correlate the flow records that it received from flow exporter. So that means flow aggregator is mainly doing some data processing with those kind of flow records, and also then the flow aggregator will also send those flow records to our final stop, which is flow collector. I think here maybe we can stop and look what kind of fields are included in those flow records, so that we can have a better idea, like knowing what are the metadata in the flow records. So we have those kind of fields. For example, we have timestamp fields, flow start seconds, which represent when the flow starts. And also we have flow end seconds, which is the most up-to-date seconds of our current flow connection. And also we have the v4 addresses and v6 addresses in separate fields. And we have port and also the packet count and byte count of the current connection, which will record like how many bytes and packets are currently flowing in this connection. And we also have the reverse count. So the packet count and byte count here means the packet counts going from source to destination. But the reverse packet and bytes means the packet and bytes going from destination to source. So that's why it's called reverse count. And we also added some Kubernetes resources specific metadata, for example, pod namespace, pod name, also destination pod name, and node name, and cluster IP, service port, and also we have a bunch of network policy related metadata here: policy name, namespace, type, role name, etc. And we also have flow type. Flow type basically represents whether this connection is a intranode connection, or it is a internode, or it stands for from cluster to external network. So these are the fields we have. Like we say, the flow records were running from flow exporter to flow aggregator and then to flow collector. Currently, we have three kinds of different flow collector. The first one is IP fixed flow collector. With IP fixed flow collector, we can kind of print out the flow records in our terminal. But we can imagine that is not so much helpful compared to UI. So that's why we also have two other kind of flow collector. The first one is ELK flow collector. This is the one which we previously supported, but now due to some license dependency issue, now it is represented. Now it is replaced by our new flow collector, Grafana flow collector. So Grafana flow collector is currently not in this diagram, but I have another diagram to include that one. Let me pull it out. Okay, so in this diagram, this part is Grafana flow collector. Basically, we have Clickhouse as our database to store those flow records data. And we have Grafana as our UI to visualize the flow records data in our dashboards. So the whole flow is like this. We have the flow records coming from flow exporter and then to flow aggregator. And we will create a Clickhouse client inside of flow aggregator. This client will insert the data into Clickhouse server's database so that we will maintain the flow records data in this table. And our Grafana UI will load those kind of data from the tables to Grafana preview dashboards. So this is the whole pipeline of how the Grafana flow collector is working with our previous building block flow exporter and flow aggregator. I'm wondering whether is that clear right now?
Yeah, it's clear to me. So can we maybe start a mirror board to put everything you just mentioned together, so like the audience can have a better understanding of this. And so for
let me see, how can I stop sharing?
I don't need to stop sharing your screen. I can start my screen. Yeah, so we can review the whole workflow here. So, if for those who are new to Antrea, we, for example, we have like a cluster here, right? Let me make it large. Is it large enough to see clearly?
Yeah.
Okay. So I have a cluster here, and in my cluster, oh my god. In my cluster, I probably have many nodes. Let's call this node 1. And probably have other nodes. I just take 2 nodes as an example. And in each node, Antrea will have Antrea agent in that node, right?
Yes.
So each node will have an Antrea agent deployed in it, right? Okay. To make this larger. Okay. So in this feature, in 1.6, we add something called we add a flow exporter.
Oh no, flow exporter and aggregator are the features we previously already supported.
Okay, it's like already supported components in Antrea agent.
That's right. We have flow exporter inside of Antrea agent. Yes.
Okay, so we have this, and each of them has one.
Yes.
And then this one is to collect the information, the flow information that is available in a contract.
node. Yes. From the contract module in a node, right?
The contract is the components in Linux kernel, right?
Yes.
So we have this flow explorer watching on this contract.
Right.
And then we have like flow aggregator. Is that in the other node in a cluster?
It can be on any node actually. It's running as a service, and the pod can be any.
Okay. So I just like take this as an example. It can be in any node in a cluster, right?
Yes.
Okay.
Right.
And these two exporter, they will tell this aggregator the information they collect from the contract, right?
Right.
And then this flow aggregator will send the information to the flow collector.
Yes.
Like this.
Mm-hmm.
And then this flow collector will send the information to the Grafana, or it's
so actually flow collector is just a concept. So here we implement a flow collector by two components. So one is the Clickhouse database, and the other one is the Grafana UI. So these two components together form our flow collector.
so it's Clickhouse is a database.
Yes.
It's part of the flow collector.
Yes.
It's like, yeah, it's just like a flow collector is just a concept. So
concept, right?
So it so the Grafana is It's the UI.
Right.
Okay, so we have like a client in this flow aggregator to send the data to the
DB.
To the DB. Let me make this more clear. To the DB, and the DB send data to the UI.
Yes.
Okay, so this two components is outside the cluster.
We deploy it also inside of the cluster.
Okay, so I should make this larger, right? It looks like this. Okay, so far, is there any questions that I can that we can answer for the audience? Let's see. I see Yang is here, Amimi is here, Jay is here. Thanks everyone for attending. And okay, I guess there's no questions so far, so we can like I'll stop sharing the screen and Anlan can go ahead.
Okay. Is there a question like Jay raised about Grafana time series database?
I don't think these are the questions about our topic.
But there is sometimes this.
I could also say some comments from audience.
I joined like what's Clickhouse. So Clickhouse is our database to store the flow records metadata. Looks like kind of NoSQL database. So Clickhouse is a column-oriented database. So where we also like maintain data in a bunch of tables, and when we insert data into those tables, we also insert it like row by row.
So each row is like each record, full record, right?
Yes, it's a record. Yes.
So it looks like a SQL database.
We can also use SQL to query that database.
Okay. Oh, I see there's a question from Jay. So was there some because probably there's my network's not great, so I don't see the comments real time. So if you guys see anything, you can like read them out, and so we can answer their questions. So was there some time series database that we use or something to aggregate the flow exporter data?
So the flow, you mean, would you like to take this one?
Yeah, I think we don't do the aggregation inside the database. Actually, we have a component called flow aggregator, which will get the flow data from flow exporter, and we'll do correlation and aggregation as this service, and then the flow aggregator will will send out the flow records after aggregation to the database. So on the database side, we don't have any aggregation process there.
Yes.
Yeah, so Clickhouse is like a regular database. It's more like a SQL database, right?
The NoSQL database, but it's
it's a
optimized.
NoSQL database.
Yeah. But we could use SQL queries. For example, in the Grafana, we are still using SQL queries to make our UI. So actually it works, but it's optimized for the read.
Okay. So is there a data? Is the question from Zach? Is there data buffering before sending data points to the dashboards to prevent data points drop?
So we have a queue. Yes.
Yeah. Maybe Anlan, you could start first.
I think. So in the Clickhouse client inside the flow aggregator, we have a queue to store the flow records that are waiting to be inserted into the table. So that kind of do the data buffering job.
Yeah, I think that's a clear answer. So I didn't draw the um, Clickhouse client in the flow aggregator, but there's one that there. And also we have other functionality in the flow aggregator. So if we have time to come back to this part later in this show, we can like explore more about what we have in the flow aggregator.
Yeah, that's correct.
Sure.
Okay.
Yeah. So like since you just say, for flow aggregator, we have three main functionalities: storage, correlation, and aggregation, which like I think can answer one of the questions that we just encountered. And if we have time at the end, Yongming will go more in detail into those three functionalities. Okay, so I think now we have a somehow a clear idea of how the pipeline is working, so that we can just jump into the demo. So currently I'm running it on a cluster where we have already flow explorer and flow aggregator deployed. So we just need to run to we just need to apply two YAML files to deploy our Grafana flow collector. So the first one.
Sorry to interrupt, but can you zoom in a little bit?
Oh yeah.
Okay, awesome.
Is that good enough?
Can you do a little bit larger? Yeah, it's good.
Okay. So I'm going to apply the first YAML file. That is the Clickhouse operator. So the Clickhouse operator is required to run the Clickhouse database in our cluster. So that is kind of a essential part. I'm going to apply it. And the second YAML file is our flow visibility YAML file. So this YAML file will deploy both the Clickhouse server and also the Grafana UI. It might take like 30 to 40 seconds to wait for all the services to be ready. So I think during this waiting time, we can also create some working load traffic in our cluster so that we have something to show later on the dashboard. I have prepared two YAML file to create those kind of traffic. The first one will create some pod to external traffic. Like we can see, we have some pod here, ping and external public IP. And also have another one here. This one will create some in-cluster networks. Basically create some pods and they will send traffic to each other. And let's see. Let's see. I'm trying to find some command that will show what kind of resources has already been created by running these two YAML file. For example, if we run this command, it should show us all the resources under the namespace of flow visibility. Let's see whether they're ready. Okay, so we have everything ready here, Grafana Clickhouse. And also I have another magical command that will print out the node IP and Grafana node port because we have exposed Grafana as a node port service here. So we have to use the node IP node port to access it. Okay, so it tells us Grafana is running on this address. We'll just copy it and paste it in our browser address line. Okay, good. So Grafana is running here. We'll use the default username and password to log in onto Grafana. The default is admin. We'll skip the steps to customize the password. Okay. So now we're here for the Grafana. Oh, I just skipped this step. So we already have some pre-built dashboard in Grafana. We can find those dashboard by clicking on the search dashboard icon here on the top left corner. So here we can see we have in total 6 dashboards. The first one is flow records dashboard. This is functioning like the base dashboard, which contains the total count of flow records we currently have in our database, and also the time series data. And also we have pod to pod dashboard, pod to service dashboard, pod to external dashboard. They are very similar. The difference is just the destination pod type, whether it's a pod or it's a service, or the destination is an external IP. And also we have node to node dashboard, and also a network policy dashboard. Let's see, currently is 0, because it takes some time for the flow records to be exported from flow exporter and then to aggregator and then to Grafana. It takes like around 2 minutes. But also we can check whether our flow aggregator and flow exporter is ready. Let's see. So currently the flow aggregator is in error because flow aggregator is previously deployed and it is waiting to be connected to the Clickhouse server. But we first start the flow aggregator and then we start the Clickhouse server. So the aggregator will hit error when it is trying to get connected to the server. Normally it will just recover in a few minutes. Yes, so it's running now. We don't need to redeploy it. So I guess we're just waiting for the flow records to be exported to our final step. It takes some time. Let me see if there are any questions.
Yeah, I think Jay has asked, can we visualize this without Grafana? And yeah, actually we have our previous version of flow character, which is called elk flow character. At that time, we are relying the Kibana dashboards to do the similar things. Yeah, definitely anything, any UI, we could do SQL queries and could display the flow records will be good enough. If we do not want to have a UI and just want to see the records, we could also use `cattle command inside the flow aggregator to get a list or a table of the currently flows inside the cluster. Yeah. Hope this answer your question.
Okay, thanks, Yongming. So currently we already have the data showing in our dashboard here. And we have in total 3 panels in this dashboard. This is the first panel, and this is the second panel, and this is the third one. The first panel showing the total count of flow records in our table. And the second panel showing the number of flow records we received in every minute. So it's a time series data here. And the third panel just displaying all the fields of every flow record we have received, like those fields we have already introduced in the documentation, the timestamp, source IP, destination IP, and also some path name, namespace, etc. And to be noticed, there are some filters that we can play with. For example, here is the time range. We can select the specific time range we want to filter on the whole dashboard. For example, if we just switch from 30 minutes to 5 minutes, definitely the total count will decrease. And also, we have a filter that will take effect on the whole dashboard. So this will allow us to select as many fields as we want. For example, if we just want to do filtering on the source path name, one source path name equal to web client 4-1, then it will only give us the flow records with source path name web client 4-1 here. And also we can add as many filters as we want. Let me just remove it for now. And also the third filter is, as you can see, we have a small filter icon on each field. If we click on it, it can also allow us to filter on this table. Okay. So that is about the flow records dashboard. If we go back to another dashboard, let's see, the pod-to-pod dashboard. We have two Sankey diagrams at the top. So the Sankey diagram will show the source path information on the left-hand side and shows the destination path information on the right-hand side. If we just hover our mouse onto the link, it will show the source path name going to destination path name and how many bytes are going through this connection. And on the left-hand side is the bytes going from source to destination, and on the right-hand side it's recording the reverse bytes going from destination to source. And besides of the Sankey diagram, we also have some time series graph here showing the throughput evolution on the pod-to-pod traffics. And also we have pie chart showing the bytes grouped by the source namespace or destination path namespace.
Okay, can we do a quick recap of what is a flow record?
Quick recap for
what is flow record?
Okay, so flow record is let me think about how to use it.
Actually in the UI showed in the flow records dashboard, we could see each row is represent a flow records. It represent the traffic between pod to pod, pod to service, and pod to external. And currently, we don't support the external to pod traffic. So basically, any traffic captured by flow exporter will be represented here.
So for every single connection, we will periodically to update the flow records and also send the most up-to-date flow records to our collector. So we will have like multiple flow records regarding to a single connection here, but they're just trying to update it the newest metadata for example, the timestamp or the packet counts, the total packet count.
So is there any way that this dashboard can tell us if a traffic is blocked or dropped by maybe the network policies?
So
Yeah.
currently we can only currently we can only see it in the flow records table if we going onto the specific fields. For example, that is the rule action one.
Right. I think we don't have traffic generate for that, but maybe we could show audience document.
Yes. That's right. So currently I didn't generate any deny never policy. So if we have that, we can like filtering on this rule action field and trying to find those connections that have the deny never policy enforced to it. But for the next release, we'll also add this part into our network policy dashboard. So currently, our network policy dashboard only visualize the allowed traffic, but for our next release, we will also add a support for the denied traffic. So those denied traffic will be represented in different colors to distinguish those from the allowed traffic. So that is a future feature that we can expect.
Okay, that's great that we have a way to handle this kind of traffic.
Yeah.
Okay.
Yeah. And see, Jay is asking why did we move from Elk to Grafana? So the reason is Elk is previously open source, but then they moved to license based. So that means we cannot just depend on them anymore. So that's why we're moving away from Elk to Grafana. And another reason is we have found some performance issue with Logstash. So Logstash is the component that the letter L stands for ELK. So the ELK stands for Logstash. Didn't they license Grafana too? Okay. I think we can move on to another topic that is doing some customization on our dashboard. For example, if we want to add a new panel on our pre-built dashboard, how can we do that? We can just click on the Add Panel button here and add a new panel. And we can select the visualization we want. For example, if we just want to do the statistic one, and then we select our data source, which is Clickhouse. And let's write some queries here. For example, if we want to select count from table flows is our table name, and we add some where source pod name space equals to default. So it will give us the total count of the flows currently in our flows table where their source pod namespace is default. And we can also view those. Oh, there's table view just showing. Yes.
So the dashboard we see previously is defined in the Grafana YAML file when we deploy this flow exporter, right?
Yes.
And based on that, we can do some like customization about the graph we want to see and the SQL query we want to like run, right?
Yeah. So for every panel, we're just doing the similar things. we write some queries, we select the visualization, and we select the data source. And we can export this dashboard into a JSON file. And we store this JSON file somewhere, and we mount those JSON file as a config map to our Grafana. So that's how this dashboard can automatically upload it to Grafana.
Okay.
And we can just click Save Dashboard here. But if we want to do something like more advanced, for example, we want to create a dashboard from scratch. We don't want just to customize our pre-built dashboard. We can just create a brand new one. So in this new dashboard, we're just doing the same thing. We add panels, and we can do multiple of them. And we save this dashboard, so it will be available here. New dashboard. But one thing to be mentioned is if we just click on Save Dashboard, these changes will only be saved for this runtime, which means if we just stop our Grafana pod and redeploy the pod, those changes will not still be there for the restart. So if we want to have if we want to have these changes saved for the restart, there are two ways to do that. The first way is we just export it and save the JSON file somewhere. And the next time we can just import the JSON file so that we can bring the dashboard back to our Grafana UI. So that's the first way. It's a manually export and import. The second way is if you want your dashboard to be automatically uploaded to the Grafana UI, just as our other pre-built dashboard, basically we have some documentation in our doc showing where you should store the JSON files so that it can be configured as a config map and mounted to Grafana. So that can be automatically provisioned to Grafana. So we offer two ways to save those customization on the dashboard.
Can you show us quickly about where those dashboard lives?
Are you saying like where those files are stored, or?
I remember there may be a YAML file that we have all the predefined dashboard that lives there.
Let me do that. So we have those. This is the flow visibility YAML file we just deployed as our second YAML file, if you still remember.
Yeah, right.
Yeah, this is pretty long because it has multiple config map. For example, this is the data schema in the form of a script. You can just fold it. And this config map contains all the JSON files of each of the dashboard.
Okay.
Like if we fold them one by one. So we have this as a config map. This is how the dashboard JSON mounted to Grafana.
Okay, so if I have a dashboard created by myself and I want to import that to the Grafana, so where do I add this file?
You will add this in the flow visibility folder base provision. It's very deep. I'm sorry about that. Dashboard. And
Oh,
here
okay.
we have all those JSON files. You just need to put the new JSON files under the same directory, and also add its name to the customization file so that it can help us to build a complete map.
Okay, so if I have like a self-built dashboard, I just need to add the files here. So when we start the Grafana pod, we have this configuration pass into the Grafana.
Yes.
Okay,
That's
gotcha.
Yeah.
Okay. And one more questions about the dashboard. So is that a real-time dashboard?
Yes, it's a real-time dashboard. As you can see, since from the time we started to now, it has already been past like 20 more seconds.
Mm-hmm.
And we have set if we set the automatic refresh to 5 seconds, it will refresh every 5 seconds. As you see, the count has already increased by 1.
Oh, yeah. Oh, okay. So we don't need to refresh this page. It's like a real
Yes, you
time.
can. Yes, that's right.
Okay, that's just like great to see that.
Mm.
Great to see the flow records with
Yeah.
the real time change here.
Yeah.
Okay.
If we still have some time, I think Yongming can elaborate more on the flow aggregator part. Just we previously had some questions on that.
Yeah, sure. I saw a question from Jack that do we scale or duplicate the Clickhouse database? Currently, since this Grafana and Clickhouse deployment is newly released in our 1.6, so the Clickhouse deployment currently is in memory only, which is not scalable. But we are currently working on to support persistent volume, and for example, user could set up the data partition, disk partition, or NFS to as the storage of the CleanHouse database. And also, we will also utilize the CleanHouse cluster in the future to enable the scalability and duplication.
Yeah, thanks Yuming for that. And I kind of see that Jay has like really great comments about this dashboard because he noticed that when we show the flow record, we not only we don't show the pod IP, we show the pod name, right?
Yeah,
so, yeah, that's like what we do in the flow aggregator to achieve this. So would you like to tell us a little bit more about that?
Yeah, sure. Alan, could you help me navigate to the document of the flow aggregator? Yes, thanks, Alan. So actually, flow aggregator is behaves like of 3 parts. The first one is called collecting process. Since there are multiple clients coming from the flow exporter are sending flow records to the flow aggregator. So the first step of the flow aggregator will collecting these flow records. And the second part is called the aggregation process. The flow aggregator will, based on the information coming from the flow exporter, for example, in the flow records coming from the flow exporter, we will have the source port name, source IP, destination IP, source port, destination port. And we will use this fab tuple to represent a network connection. And this fab tuple consists of source IP, destination IP, source port, destination port, and transport protocol. With this fab tuple, we could identify a single network connections, and all the flow records coming from flow exporter have the same fab tuple. We will do the correlation and aggregation here. The interesting part here is that if there is a flow records which is correlating to internal flows, such as the source port and destination port are located in different nodes. So in that case, after the correlating, the flow records coming from the source node flow exporter will have the information of the source port. The flow records coming from the destination node flow exporter will have the information of the destination port. In this case, we could do the correlation here, and the flow records sent by the flow aggregator will have the port name for both the source port and destination port. We could do more beyond the correlation here, since we have the more information here. And for example, the flow records sent by the flow aggregator will also have the throughput information based on the flow records. We will have this calculation logic here, and also we will involve the source port labels and destination port labels here in the aggregate flow records, which will be also useful for user and our future visibility application here.
Okay.
Yeah, and the third part of the flow aggregator is the exporting process. After we finish the correlation and aggregation, we would like to send out our flow records to the flow collector. As we can see that if it's a simple IPFix flow collector, we will send through the IPFix protocol. If the flow collector is our new Grafana flow collector, we will use the Clickhouse client to send out the flow records directly into the database. Yeah, basically that's what the flow aggregator do. And if you are interested, we also have the uncutter support for the flow record. If you do not want to set up a Grafana flow collector or Elk flow collector, you could simply log into the flow aggregator port and run some uncutter commands. It will also give you the flow records inside the flow aggregator.
Yeah.
Okay.
Yeah.
So basically, what you are saying is that from this graph, we can see that each flow exporter only run in each node, right? So I can only see the information within this node, but the flow aggregator here collect all the data from each node. So the flow aggregator has the information in the cluster scope, not within like each specific node. So it
Right.
can like show the traffic between the node
Different nodes.
and right. And also here we can see that this flow aggregator like talk to this Clickhouse DB. But if we want to like only extract data from the flow aggregator, we can also talk to these components directly.
Using uncutter,
Yeah.
like other components in Antrea.
Yeah. That's like really flexible. Okay. So
yes. And I see Zach is asking a question about for the current behavior data are in memory when the data storage usage exit the memory allocated, I assume the pod will restart and previous data will disappear. So that is actually a very good question. To prevent this kind of situation, Xinqi, could you just let me to share my screen? Yes. So we have added two data retention methods to prevent this kind of data restart. So for these two methods, the first one is TTL mechanism. So basically, TTL will periodically delete the expired flow records in our database. That can help reduce the size of our database. And the second method is Clickhouse monitor. So the monitor is designed to deal with when sometimes there is a burst in the data insertion, so that the Clickhouse will monitor the memory usage of Clickhouse, so that it can help to delete some of the flow records if the memory usage is larger than a threshold. So in total, we have two data retention methods to help deal with the memory usage thing. I hope that can answer the question.
Yeah, I think this is a great answer to this question.
Mhm.
And is there any other questions? By the way, if I remember correctly, it's the first time in our Antrea show that we cover the flow of visibility part. And it's like really thanks to Anlan and Yongming to tell us a little bit about this aggregator. No, about this like the dashboard, and we can of course like use that to troubleshooting the cluster or like do some statistic based on the beautiful dashboard we built. So thank you both for telling us this, and also, I don't really see any other questions in the comments. Okay, so if there's no more question, we will like thanks every audience for attending this show, and if you like this kind of context, consider liking our videos and subscribing the channel. And okay, so I'll see you guys next Wednesday. Bye.
Thank you.
Thank you.
Goodbye.
Thank you. Bye bye.